Hi, this is the code demonstration walkthrough of the report. I wanted to capture straight from my screen, but I'm having some issues capturing audio with my computer for some reason, so I'm just gonna go ahead and do this real quick. Um, so I'll start at main.c. You'll see I have all my global variables defined up here. I begin by initializing all of the proper peripherals. These four peripherals are ones that I've written per the specifications of the lab. And then I set up my UART to receive 4 bytes of data. And then basically I sit in a while loop that has a delay for 1 second. And then if my increment flag is set to 1, I increment the counter value once a second. If the counter is going above 7, I reset it down to 0. And then I update my GPIO pins for the LED outputs. For my sys clock init that's called in main, I have this function that's basically setting it up per the specifications of lab 3. For sysclock, AHB, APB1, and APB2 are set to 64, 64, 32, and 64 megahertz respectively. This was verified in lab 3, so I believe everything should be good here. We have the error handler here. Moving on to the GPIO, I'm enabling the GPIO clocks for ports A, B, and C. I'm configuring ports A1 and 4, A0, 1, and 4 as inputs for the push buttons. Port C, pin 13 is the blue reset button. And then we have the outputs on C8, C6, and C5. I set the priorities to 0 to be the highest, and then obviously enable the IRQs. I have this callback for overriding the way that the interrupts are handled. I'm debouncing by using the get tick function. Every time an interrupt is triggered, I use get tick to figure out if 200 milliseconds have passed between the last time that an interrupt was triggered. If there was, that means that we've debounced it successfully. And then obviously there's the different ext button functionalities for the different buttons. Now to get to the meat of the project, the HAL UART MSP init function was overwritten from the weak one that's provided in the HAL functionality. This is provided by the instructor. It configures the USART1 and USART2 to behave properly as expected. So yeah, this is just a copy paste from the code that Professor Crum posted on the discussion forums. I have separate functions for USART2 init and USART1 init. I'll start by looking at USART2. It's basically configured for 115200 baud, RX and TX mode. I initialize it, and then this goes on and eventually calls this MSP init function that we just talked about. I haven't configured this for interrupts because the USART2 is a debug port that I was just using to plunk stuff down onto a COM port. That was just for debugging. I didn't see the point of having interrupts triggered for that. For USART1, we have 115200 baud again, but this time I write the control register 1 RxNEIE bit to be 1 so that it generates an interrupt every time a receive is triggered. And then I set the priority to be a little lower than the ones for the GPIOs. I figured that made a little bit more sense. And then if we take a look at the IRQ handler, I call the IRQ handler from the stm32f1xxit.c file. And what this does is once it receives the 4 bytes as specified from main here, it will call this guy, the UART-RX callback. What this does is it bit shifts the values to see if we've gotten the correct sync pattern. Once we verify that we have the correct sync pattern, we receive 1 extra byte for the packet size. If the packet size is 7, we receive 2 more bytes. If the packet size is 8, we receive 3 more bytes. I plop down the command code and the checksums in the appropriate from the appropriate buffer places, and then from here I calculate the checksum. The calculate checksum function returns a 1. It returns the checksum value that is computed. If it's equal to the checksum that we received over the UART, then we go ahead and execute the command. If the execute command function returns a 1 or a 0, depending on if it's valid or not. If the command was valid, we return a 1. So if the command was properly executed, we execute a transmit NAC. Otherwise, we send a NAC to say that the command was invalid. Obviously, if the checksum doesn't work out, we send a NAC as well. And then if the receive pattern is not the correct value, then we send a NAC as well. So from here, we rearm to receive another 4 bytes of data. So as far as debugging and stuff goes, I ran into a lot of issues getting this portion of the callback portion to work. The debugging steps I took was to plunk down a bunch of printf statements that were printing out to USART2 for my command. That allowed me to verify the data that I was receiving and see if I was getting the correct data. I ran into a lot of issues with not knowing to rearm this guy. I had to do a lot of digging to figure out that this is the proper way to call this function. So I rearm it at the end of each of my transmits. I think that about covers everything. I'm not sure if I'm missing anything here, but if I have missed something, please let me know. I hope this satisfies the requirements for the thorough video. Thank you.